Hey guys, today I'm going to go over projections. Let's say I have some vector b, and I'm starting at this point where vector b ends. What is the closest way I can get to any point on vector a from this point on vector b? Well, of course, the easiest way to do that is by going straight down. Because if you go this way, well, that line's longer than this line, and if you go this way, that line is also longer than that line. And what this does is actually creates a perpendicular angle right here between B and A. And the way to make this line that goes straight down, well, that's called a projection. And it's kind of like casting a shadow over A. And when you cast a projection, what you get back is this point over here that is formed on vector A. The projection of B onto A is written like this. Projection of B, but it's onto A, so you write a subscript here. Well, that's just equal to A dotted with B divided by A dotted with A, and then you multiply that by A, just A. So now I'm going to do an actual example with my A of 3, 1, and my B of 2, 3, and I want to make a projection, and it would look something like this. And as you can see, it looks a little bit smaller than what A actually is. But let's calculate it with the formula up here. So A dotted with B, that's just 2 times 3 is 6. And then 1 times 3 is 3. If we add that, we get 9. Now, A dotted with itself, 3 times 3 would be 9. And then 1 times 1 would be 1. 9 plus 1 is 10. So, the vector A will be scaled by 9/10. So 9/10 times 3, 1. Well, that's equal to 2.7 and 0.9. And as you can see, this value is just a little bit smaller than our original A, like our graph is showing over here. Another thing that's interesting is that if you take our original vector B and subtract it by this projection over here, you get this vector. And if you graph that vector, approximately, you get this vector over here. And if you look closely, it's actually orthogonal or perpendicular to our projection. And you can do the dot product to confirm this, but as you can see, this method, if you subtract B by the projection, you get the vector that's perpendicular to the projection. And that makes sense because that's just this vector over here. If you minus this and this, you'll get this. I hope you enjoyed this video, and I'll see you in the next one.